Yes, good morning to all of you.
Good morning, ma'am.
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 Good morning. So, before starting with the practicals, yesterday, sir has started or not?
No,
No, ma'am.
Okay. Yes, Somaran Kumar. Please mute your mic. Okay, so today we will start our practical. So, before starting with the practicals, main practicals, that is from the experiments, we must know what all terminology we are going to use, which type of viva questions can be asked, what is the basics, what are the basics which are involved in these experiments. So all these things you must know. So for this, the first class, this class is only for the introduction to the chemical analysis. It will be an introduction to the chemical analysis, and a number of questions are asked in Viva from this part. Because you must know what is quantitative, what is qualitative analysis, what are the different types of qualitative and quantitative analysis, then what is volumetric analysis, what is gravimetric analysis, all these things, what is the main concept behind each analysis, that you must know. So, in addition to this, about indicators, what are indicators, what are the different types of indicators, examples of indicators, structure of indicators, then about the concentration of the solution, what are the different methods of representing the concentration of the solution. So all these things, a number of questions are asked from this part in Viva. So what you have to do is you have to prepare a practical record. It is up to you whether you are making a practical record in the form of copy, practical file, which comes in the stationery interleaf copy. You can make it in that way, or you can make it in paper, okay, in simple A4 size paper. And because you have to finally make a PDF, but if you make a notebook, then it will be beneficial for you only to keep the record properly. And if you make it in papers, then you will only have to arrange it properly. Okay, so the first thing which you are going to do, it is up to you. You can make notebook, or you can make it in A4 size papers. Okay, so there is no restriction. You can make it in any way, and finally you will have to convert it into PDF, and then only you will have to submit. So the first thing which you are going to do is you will have to write your name, roll number, section, everything, and then you will start with index. Okay, index should be properly written with date, name of the experiment, and when it is done. Okay, like name of the experiment. Suppose first experiment. This is not the first experiment which we are going to do today. Today we are going to do only the introduction. So you will write date, today's date, in the date section, and name of the in the name of the experiment you will simply write introduction to chemical analysis. Okay, introduction to chemical analysis. Experiment number you will not write because this is not an experiment. You will write only the introduction to chemical analysis, and then you will write the page numbers like this. From second class, from the second practical class, experiment number 1 will be started. So at that time you will write experiment number 1, experiment number 1, and then name of the experiment, the complete object, and page number. Like this you will prepare the index. After index, the first thing which you will write in your practical record is introduction to chemical analysis. This should be written. Okay, this should be written in your practical record. Today only I will share it in the classroom. Go through it and write it. I will explain each and everything. So it will be means it will be better for you to write because a number of questions are asked from this part. Okay, so let's start with today's part.
Ma'am, are you sharing screen with us?
Yeah, wait a minute, I'm sharing. Actually, it is a PDF. Yes. Is the screen visible?
Yes, ma'am.
Visible.
Yes, ma'am.
Yes. So chemical analysis. Introduction to chemical analysis. So what is chemical analysis? Chemical analysis is the detection and determination of constituents in a substance by various process, by different process. So whatever substance we are provided with, if we have to determine the constituent elements present in it, if we have to determine the constituent elements present in it, then it is called chemical analysis. Which substance is provided to us? Any chemical substance. So whenever any chemical substance is provided to us and we have to determine and we have to detect the constituents present in it, then it is called chemical analysis. So chemical analysis is of two types, qualitative analysis and quantitative analysis. Qualitative analysis, the name itself is giving you the answer. What is qualitative analysis? Which determines and detects the quality of the constituents present in a substance. For example, salt analysis, inorganic salt analysis. So inorganic salt analysis, what we do? We determine different cationic radicals and anionic radicals, acid radicals and basic radicals in the inorganic salt. So these radicals are going to determine the quality of the substance, which type of substance it is. So that is qualitative analysis. Similarly, if we determine the functional group in organic compounds, functional group analysis is also a type of qualitative analysis, because through functional group analysis also we conclude the nature of the compound. Okay, we conclude the nature or the quality of the compound. So that is a type of qualitative analysis. So already you have done qualitative analysis, I think in 11th and 12th standard.
Yes, ma'am.
Yes, ma'am.
Okay. So for inorganic salt analysis and functional group analysis are qualitative analysis. This thing we are not going to do this year, but you must know with examples what is qualitative analysis and what are the examples of qualitative analysis. Then the next thing which is there is quantitative analysis, in which the quantity of the substance is determined. When the quantity of the constituents present in any substance is determined, it is called quantitative analysis. Okay, so quantitative analysis is of two types mainly: instrumental analysis and non-instrumental analysis. So instrumental analysis, when we determine the quantity of any constituent present in a chemical substance with the help of instrument, with the help of any instrument, then that is called instrumental analysis. For example, spectrophotometric determination is the type of instrumental quantitative analysis. For determining the concentration of different substance, for determining the concentration of the constituent present in any substance, spectrophotometric method can be used, spectroscopy can be used. And how this spectroscopy is done? With the help of spectrophotometer. Means this determination involves the use of an instrument spectrophotometer. So it is instrumental quantitative analysis. Similarly, conductometry, conductivity measurement, conductometry, that is also a quantitative analysis. pH metry is also a quantitative analysis. So all these, then colorimetry, then a number of methods are there which are quantitative instrumental analysis, which involves the use of different instruments for the determination of quantity of the compound. Then non-instrumental, you are going to do only non-instrumental. So non-instrumental quantitative analysis, when there is no need of any specific instrument for the determination of the quantity of substance present in any quantity of the constituents present in any substance, then it is of different types like volumetry, gravimetry, electrogravimetry, and titrimetry. Generally, we refer titrimetry and volumetry as same. Volumetry and titrimetry generally we refer as same, but what is titri? Why we have separated here titrimetry? Because mainly you are going to do titrimetry this year only. Only titrimetry you are going to perform this year. So let me explain each and every method. Volumetry. Volumetry is determination of the quantity of or the volume of any substance with the known volume of one substance. Okay, with the known volume of one substance, that is called volumetry. Gravimetry, when the quantity of the other substance, when the quantity of any constituent, you can say, when the quantity of any constituent is determined by converting that substance into precipitate and by weighing that precipitate. So how gravimetry is done actually? Suppose we are provided with a clear solution, and in that clear solution, we have to determine the amount of any constituent, any one constituent. For example, I am taking, we are provided with a barium chloride solution. We are provided with barium chloride solution. Barium chloride solution is a clear solution in water. Now we have to determine barium ions concentration or the amount of barium ions present in this solution. So just by looking into this clear solution, we cannot conclude the amount of barium ions present in this solution. Okay, so what we do is we will convert the barium ions in this clear solution into insoluble precipitate. How we can convert it? We add in it dilute sulfuric acid in excess. So when we add dilute sulfuric acid in it in excess, all the barium ions form barium sulfate precipitate, insoluble precipitate. Now we filter the precipitate, dry the precipitate, and then we weigh this precipitate. The weight of this barium sulfate corresponding to the amount of barium present in it will give the amount of barium ions present in the whole solution. Got it?
Yes, ma'am.
Okay, so this is gravimetry. When we are provided with any clear solution or we are provided with a salt and we have to determine the concentration of any constituent, then we can convert that constituent into insoluble precipitate, and then through that insoluble precipitate we determine the concentration of a particular ion. Okay, and that this is called gravimetry. The same procedure when done with the help of electricity. When the same procedure is done with the help of electricity, it is called electrogravimetry. Then titrimetry. What is titrimetry? When we use a standard solution. When we use a standard solution and with the help of standard solution, we determine the concentration of the other solution whose concentration is not known.
Ma'am, sorry to interrupt, but whatever you are saying, are you presenting it or you're just
I am
narrating it?
presenting it. See, I have shared the screen.
I can only see from
Screen.
the beginning, only see one slide.
Are you scrolling it?
This is the first slide only because so much matter is there. We have moved from qualitative, quantitative I have explained, then instrumental, non-instrumental I have explained. After this volumetry, gravimetry, electrogravimetry. All these three I have explained. Now we have came to titrimetry. Screen is not visible?
Visible, ma'am.
Visible, ma'am.
Will you provide us notes? Whatever you are explaining, will you provide us notes?
Listen it carefully. You will not get notes anywhere. It is not given clearly. Note it down. It is not given separately in any of the books. Okay, that is why I am explaining. Then titrimetry. In titrimetry, you will be provided with two solutions. One is a standard solution and other one is unknown solution. One is standard solution. Standard solution means solution whose concentration is known. So you will be provided with two solutions. One is a standard solution and the other one is unknown solution. And with the help of this standard known solution, when you determine the concentration of the other solution, that is unknown solution, then that process is called titrimetry. Okay? Is titrimetry clear?
Yes, ma'am.
Yes, ma'am.
So you will do titrimetry only in this semester. All the experiments are based on titrimetry. That is, you will be provided with a standard solution and with the help of that standard solutions, you will have to determine the strength of the unknown solution. This is the only thing which you are going to do through titration. You have already performed titration in 12th standard. So I think there is no problem in how the burette is filled, how we see the least count. All these things I think you all are knowing because you have done this experiment titration in 12th standard. Is there any doubt in titration?
No, ma'am. But, ma'am,
No,
can
ma'am.
you once just explain instrumental versus non-instrumental?
Instrumental versus non-instrumental. See, when we do not use any specific instrument for quantity determination, then it is non-instrumental. For example, this volumetric analysis, we do not use any specific instrument. Simply we mix different volumes of the solution. And by mixing the volumes only, we determine the concentration. Like in gravimetry, we are converting the solution into precipitate form, filtering the precipitate, drying the precipitate, and then we are weighing it. Means we are not using any specific instrument here. In electrogravimetry also the same procedure, in titrimetry also the same procedure, where we do not use any specific instrument for the determination of the quantity of any constituent. It is non-instrumental. And instrumental is when we use a specific instrument like spectroscopy. Spectroscopy is carried out. It cannot be carried out without spectrophotometer. हम सिंपली विदाउट स्पेक्ट्रोफोटोमीटर हम स्पेक्ट्रोफोटोमेट्री कर ही नहीं सकते, है ना. इट रिक्वायर्स स्पेक्ट्रोफोटोमीटर. सो व्हेन एनी इंस्ट्रूमेंट इज एसेंशियल, देन इट इज instrumental analysis.
Yes, ma'am. Got it.
Now titrimetry. In titrimetry, there are different types of titrimetry depending upon the chemical reaction which is taking place during titration. So first type is acid-base titration or neutralization titration. When in our titrimetry, the reaction that is taking place is neutralization reaction, then it is called neutralization titration or acid-base titration. Second is redox titration. When in our titrimetric experiment, when there occurs redox reaction, that is oxidation and reduction, it is called redox titration. When in our titrimetry precipitation reaction occurs, then it is called precipitation titration. If complex formation takes place, it is called complexometric titration. So depending upon the type of reaction that is taking place in our titrimetric analysis, we have divided it into neutralization titration, redox titration, precipitation titration, and complexometric titration. Now, in titrimetric analysis, two things are to be remembered. One is titrant and other one is titrand. So titrant is a solution of known concentration, means standard solution. Standard solution is called titrant and titrand, the solution whose concentration is to be determined, means unknown solution. Unknown solution is titrand. Then there are different indicators which we will use, like methyl orange, phenolphthalein, and phenylanthranilic acid, and EBT, that is areochrome black tea. These indicators we are going to use: areochrome black tea, methyl orange, and phenylanthranilic acid, and phenolphthalein. Methyl orange and phenolphthalein we are going to use for our neutralization titration. Areochrome black tea we will use for our complexometric titration, and phenylanthranilic acid we will use for redox titration. And other than this, we will also use a self indicator, that is potassium permanganate. That will also be used in our redox titration only. So you will have to remember the structure of methyl orange, change which takes place in the structure when it moves from acid to basic medium, why the color change occurs, what is the change in color, and what is the different structure which is obtained in acidic medium and in basic medium. This is only because of the oxidation of this indicator. Okay, the structural change takes place mainly because of the oxidation which takes place in the indicator. And as a result of this oxidation, the structure also changes. So methyl orange and phenolphthalein, their structure in acidic and basic medium, both you will have to remember. Then N-phenylanthranilic acid. N-phenylanthranilic acid is the indicator which you will use in redox titration. In redox titration, you will do two types of titration. One is by using potassium dichromate as oxidizing agent, and other one you are going to use is potassium permanganate as oxidizing agent. So when you use potassium dichromate as oxidizing agent, in that case you will use N-phenylanthranilic acid. In N-phenylanthranilic acid, the structural change takes place because of oxidation, and because of oxidation it dimerizes. two molecules of N-phenylanthranilic acid combine together and it dimerizes. So due to this only, the change in color occurs. When we discuss individually about each experiment, at that time I will explain it properly in detail. For now, you must remember that you will have to remember the structure of these indicators which you are going to use. Now, endpoint and equivalence point. These are the two terms, endpoint and equivalence point. So what is endpoint? Endpoint is the physical observable change. It is the physical observable change that takes place in the solution. You have already done titration, so you might have seen that after performing the experiment, there occurs a color change, and when color change is seen, at that time you stop the experiment and you note down the burette reading, and that is called as endpoint. Isn't it?
Yes, ma'am.
So endpoint is the observable physical change. It is the observable physical change in color that occurs in the solution. And equivalence point is the point which is achieved before the endpoint. Actually, endpoint comes afterwards. And equivalence point is achieved before. Suppose we are performing our neutralization reaction, neutralization titration. So after complete neutralization, and we are adding, suppose in neutralization reaction, we have taken acid in conical flask and we are adding base from the burette. Now, after complete neutralization, when we add few more drops of base into the conical flask, at that time only endpoint we will get. But before endpoint only the reaction is completed. So that point where the reaction is completed is equivalence point. So equivalence point is always before the endpoint. Got it?
Yes, ma'am.
You should not have any doubt in endpoint and equivalence point. Mostly it is asked.
Yes, ma'am.
No doubt?
Ma'am. Ma'am.
Yes.
Ma'am, our aim is to bring endpoint or equivalence point.
You have, without endpoint, you cannot conclude that reaction has completed. Na? You will have to achieve endpoint.
Okay, ma'am. That means we have to add excess amount of base in
Yes.
acid.
Yes, yes.
Okay, ma'am.
So
Madam,
endpoint, yeah.
how to observe equivalence point? Means we can't get any physical change.
That is what we cannot observe equivalence point, because till the completion of the reaction, there is no physical change that occurs. The physical change which is observed in the form of change in color will be only after the addition of excess of titrate. Okay, it will be only after the completion of reaction. If we add even 1 or 2 drops in excess, that only gives the physical change, that is change in color. That is because of the change in the structure of the indicator. Okay.
Madam, if we add excess, then there is a wrong result, no, ma'am?
No, that is negligible actually. That is negligible. That is why there are so many other techniques which can be used for, if we are doing it for any research purpose, then there are some other techniques which we do, okay, which we perform. When there is no need of any high accuracy, at that time only we use this technique, where 1 or 2 access drops are not going to make any change. Okay.
Yes, ma'am.
So you must remember what is endpoint and what is equivalence point. Equivalence point is achieved before endpoint, but we cannot see that equivalence point because it does not appear in the form of any physical change. Then standard solution. Already I have told you what is a standard solution. Standard solution is a solution whose concentration is known. Whose concentration is known, it is prepared from highly purified form of salts which are stable in different environmental conditions. This salt should be readily soluble in water or in any of the solvent in which we are preparing this solution. They should possess a large equivalent weight or molecular weight so that weighing error can be minimized, because if they have a small molecular weight or equivalent weight, then what will happen? During weighing and during transferring that weighed amount of the substance into the flask for preparing the solution, there are chances of error, because if the substance is a low molecular weight substance, then what will happen? It will stick into the Petri plate in which we have weighed. It will stick into during transfer into the flask also. There are chances that it may stick to the walls of the flask. So there are chances of error, and even a small amount will produce a large error. So generally for standard solution preparation, we prefer equivalent weight and molecular weight to have high. Then the error in determining the endpoint must be negligible. There are 2 types of standard solutions, primary standard and secondary standard. So primary standard solution is the solution which is prepared and which can be prepared and stored for a long time, whose concentration does not change. For example, if we prepare NaCl solution, N by 100 and we keep it for a week, and after a week if we observe the concentration, then again after a week also the concentration remains constant, N by 100 only. But there are certain salts whose concentration changes. Suppose we have prepared now N by 100, it may change to N by 80 after a week. Means we cannot store it for a long time. If we have to use the same solution after 1 week, then again we will have to standardize that solution. So it always needs a standardization before use, like potassium permanganate solution, like ferric chloride solution, potassium hydroxide solution. All these are the solutions whose concentration changes with time due to environmental conditions. So they are called secondary standard solutions. They are called secondary standard solutions. Therefore, they are also, why they are called secondary standard solutions? Because they can be prepared from primary standard solution. Primary standard solutions are the solutions whose concentration does not change with time. They can be stored for a longer time. Okay. However, secondary standard solutions are the solutions whose concentration changes with time. They cannot be stored for a longer time, and they can be prepared from primary standard solution. Got it? Now, why this change occurs, why this change in concentration takes place. There are certain salts, like you might have seen NaOH pellets or potassium hydroxide pellets. When we keep these pellets in open, what happens? They absorb moisture, they start melting. Okay, they start melting. So all those salts, like the salts which absorb moisture or which loses moisture in the presence of air, so all these deliquescent hygroscopic efflorescent salts which have the capacity to do this, either by absorbing moisture, they change into liquid form or they melt. So these type of substances, they mainly change their concentration. Like ferric chloride. Ferric chloride is the substance which is highly hygroscopic in nature, which absorbs moisture and it readily turns into liquid form. So we generally keep ferric chloride in brown bottle so as to avoid its contact with light, and we cover that bottle with calcium chloride covering, a thick calcium chloride covering like plaster. Plaster is done over that bottle so that no contact with air or moisture should be there to store this ferric chloride for a long time. Even then, if we keep this bottle open for some time, it readily absorbs moisture and gets converted into liquid form. When it is absorbing moisture and converting into liquid form means obviously it is changing its concentration. If we prepare the solution of this substance, it will change its concentration after some time. So that is the reason there are certain substances whose standard solution, if once prepared, cannot be stored for a longer time. Got it?
Yes, ma'am.
So they
Yes,
are called secondary standard substance. Now indicators. So indicators are those substances which are added to the reaction mixture to indicate the end point. Indicators are the indicators of the end point. They show the end point of the reaction by the change in color. So it mainly depends upon the pH. So you must remember what is pH. Okay, what is the mathematical expression of pH? All these things also you can be asked based on the indicator. Then types of indicators. There are 3 types of indicator: internal indicator, external indicator, and self indicator. So internal indicator is the indicator which is added into the reaction mixture directly. Like methyl orange or phenolphthalein, they are added into the reaction mixture. So whatever indicators you are going to use in this semester will be internal indicator only. Internal indicators are directly added into the reaction mixture and they show the end point by the color change. External indicator. See, there is a lot of difference between internal indicator and external indicator. Internal indicator is directly added into the reaction mixture 2-3 drops and they show the change in color as endpoint. External indicator, what is external indicator? When we do not add the indicator directly into the reaction mixture. When we do not add the indicator into the reaction mixture, then how we do this experiment, how we perform the experiment? What we do is we take a grooved tile, a tile having grooves. It comes generally in the scientific store. Grooved tile we take. Grooved tile is similar to the watercolor which we use. You might have seen the box of watercolor. All of you have seen?
Yes, ma'am.
Yes, ma'am.
grooved tile is similar to the watercolor. When we remove all the colors, what is there? Only grooves, only compartments are there.
Yes, ma'am.
So grooved tile is just like that. A tile with grooves, small grooves. So in those grooves, we fill 2 to 3 drops of indicator. And we perform our experiment as we usually do the titration. Then what we do after certain interval of time, we take out 1 to 2 drops of our reaction mixture and we put 1 drop of the reaction mixture into one groove and we observe the color change. If it changes the color, then we note down the burette reading as the endpoint. If it does not change the color, then we continue the experiment. Okay, we continue the experiment. And again, after a certain interval of time, again, we take out the reaction mixture. We put 1 drop of reaction mixture into the indicator taken in the groove tile. And again, we observe the color change. So because we are not adding the indicator into the reaction mixture, it is external indicator. But generally, the use of external indicator is avoided because there are a number of drawbacks in this. First thing is the whole concentration of the reaction mixture is going to change because we are taking out 1 to 2 drops each time. Second thing is it inserts contamination, it introduces contamination. Okay, it introduces contamination into the reaction mixture. Thirdly, the reading which we obtain with external indicator will not be very accurate. Got it?
Yes, ma'am.
So the example of external indicator is potassium ferrocyanide, potassium ferricyanide, all these are the examples. Then another is, third type of indicator is self-indicator like potassium permanganate. There are certain substances which are present in the reaction mixture which are in colored form and they themselves act as indicator. So they are called self-indicator. So self-indicators are the indicators which are present as a reagent in the reaction mixture and which act as indicator. Like potassium permanganate is purple in color. When we perform titration, it changes from purple to colorless. Okay, so sometimes this color change appears, sometimes potassium permanganate is there in the solution, but the solution is colorless. And at the end point, this potassium permanganate shows its color in the form of purple. There is no need to add any indicator into this reaction mixture because already potassium permanganate is acting as indicator. So such type of indicator is called as a self-indicator. Got it?
Yes, ma'am.
Yes, ma'am.
Then acid-base titration. When we perform all these titrations, at that time only, I will explain each and everything. What is acid-base titration? Simply, I have told you what is acid-base titration. It is a type of neutralization titration. Now, 2 types of titration are there in neutralization titration. One is alkalimetry and other one is acidimetry. Alkalimetry and acidimetry. So what is alkalimetry? When we determine the concentration of alkali by using acid, it is called alkalimetry. And when we determine the concentration of acid by using alkali, it is acidimetry. Then redox titration. In redox titration, we will perform permanganometry, dichrometry, iodometry, and iodimetry. All these experiments we are going to do And when we perform this experiment, when we do this experiment, at that time I will explain it in detail. It mainly involves the use of oxidants and reductants, oxidizing agents and reducing agents. These are the important reactions involved in all these type of
Ma'am, please provide this PDF in Google Classroom.
Yes, I will provide. Then concentration terms. Already in solutions, chapter solutions in 12th standard, you have done all this. What is normality, what is molarity, what is molality, what is mole fraction. You all are knowing all this. Do you know molarity, normality, molality, all these
Yes,
things?
ma'am.
Mole
Yes,
fraction?
Yes, ma'am.
Yes, ma'am.
So this also you must remember, the concentration terms, how to represent the concentration of different solution. We can represent the concentration in the form of normality, molarity, molality, mole fraction, all these things. So in the form of formality also we can determine. So that only is written. Today, now tell me, is there any doubt anyone is having?
Ma'am, please repeat the format of index.
Ma'am, term project लिख दो.
Term project.
Ma'am,
How
the
will-
format of
main
index.
content
Okay,
है ना,
index.
ma'am?
Wait a minute. In index, what you will do, make the copy. If you are using the copy, already the format of the index is provided. Serial number, then date, experiment number, name of the experiment. And then you will leave space for signature.
Ma'am, the same format which is given in practical file.
Records. Yes.
Okay.
Serial number, then date, then experiment number, name of the experiment, and then signature.
And ma'am, on index page only we can write our name, roll number, section.
Yes,
branch.
because you will make PDF, no? So in index only, don't waste pages.
Ma'am, will you provide the content of experiment?
Yes, we will provide. And one thing I want to tell you, start preparing your practical record. After each experiment, start writing the practical in your records. So first thing which you are going to do is you have to write this, Introduction to Chemical Analysis. This will be the first thing which you are going to write. Because from second experiment, means from the first experiment, you only have to write the object. You don't have to write the whole procedure and all. You will write the object, apparatus required, observation table, and calculation. Then structure of the indicators, equations, whatever is there, that only you will write. The theory, procedure, all these things is not required. You will write only the aim of the experiment, apparatus required, then the observation table, calculation. Plus, if the structure is, if the indicator is there, then indicator structure and equations. These things only you have to write. Okay.
मैम टर्म प्रोजेक्ट में लिटरेचर रिव्यू के बाद मतलब लिटरेचर रिव्यू के अंदर लिखना है ना जो मेन कंटेंट्स है लाइक एप्लीकेशन ऑफ इलास्टोमर यूजेस एंड
No. See, don't confuse with literature review and your content. Your content will be there in the methodology part. Okay. Your content will be there in the methodology part and you will explain it in short in the abstract. What is literature review actually? Literature review is the work which is already done by different researchers in past 10 to 20 years. So you will give the year-wise description. Okay. For example, in the year 2017, this and this scientist's name okay, has made a research in this field and concluded that, like this, you will write.
Ma'am, we can use A4 site for term project.
What?
मैम वो एक्सेस करने में प्रॉब्लम जा रहा है मैम, लाइक मेरे को अभी तक एक ही रिसर्च पेपर मिला, बाकी फुल एक्सेस मिल नहीं पा रहा।
नहीं तो फुल एक्सेस सब में रहता भी नहीं है. यू विल हैव टू परचेज एंड देयर इज नो नीड टू परचेज एनीथिंग. देयर आर सो मेनी फ्री रिसर्च पेपर्स. इफ यू आर गेटिंग द एब्स्ट्रैक्ट, है ना, द एब्स्ट्रैक्ट इज जनरली फ्री. Abstract of every paper, almost every paper is free of cost. So take the printout of that abstract. In abstract only everything will be written over there. That we have performed the experiment by this and this method and we got this and this result. All these things are
so abstract
mentioned.
will be enough to, like, abstract will be enough to write contents.
Yes, abstract will be enough to write the review of literature. कि इस ईयर में इस साइंटिस्ट ने ये वर्क किया और उसने पाया कि ये ऐसा इस तरह से होता है. दैट ओनली.
मैम जो मेथोडोलॉजी है वो उसके लिए बुक को एज रेफरेंस ले सकते हैं.
हाँ, कुछ भी ले सकते हैं.
Ma'am, we can use A4 size paper for term project.
Yes. Okay, and later on I will assign it in the classroom, so you can give that particular date in which I have assigned.
Ma'am,
Okay.
we can only write a paper, or we can make a word of it use.
What?
मैम सिर्फ राइट उसको लिख ही रहे हैं A4 साइज पेपर पे, या फिर हम लोग उसको MS वर्ड में बना भी सकते हैं ऑन लैपटॉप?
That only you have to do. You have to type. If there is no provision of typing, if you don't have any laptop or computer, then you can simply write it in A4 size paper. Otherwise, you will have to make it in typed form.
Okay.
Ma'am, can you provide a PDF of this?
Which PDF?
Today lecture.
Yeah. Now only I will share it.
Okay.
Okay. You can leave now.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.